So our next question we want to look at is question 2. So what's this to graph the function f of x equals the quantity x plus 5 squared minus 3 by starting with the graph of y equals x squared and then using transformation shifts, shifting, stretching, compressing, and or reflecting. So again, just remember, if we're outside the function, this is going to be a vertical, so this would be an up. If we have a minus on the outside of something there, a minus some number, that's going to actually make the graph go in a down movement. Now remember, when it's inside like this, if it's inside the function, this is actually going to be backwards, so that's actually going to be a left. And if it's inside at a minus, remember it's backwards, we're actually going to be going to the right. So if I look at the parent function, it's going to be y equals x squared. So if let me make this a little bit better, make a little table. So remember, if I already know that this is kind of a parabola shape, then all I really need are 3 critical points. So -1, remember -1 squared was 1, 0 squared was 0, and then 1 squared was 1. So if I want to graph the new function, which is y equals this x plus 5 squared minus 3, what we should pick up on is the inside should make the graph move left. So I should be subtracting 5 from these x values. So that would make this a -6. That would make that a -5. And that would make this a -4. And on the outside, notice how we have this -3. Notice how that's actually going to make the graph move down. So I should be subtracting 3 from the y values. So 1 minus 3 would be a -2. 0 minus 3 would be a -3. And 1 minus 3 again would be -2. So that's the order pairs we should be seeing. So again, if I was using my graphing calculator, we have y equals, again, if I put that parent function back in, x squared, and then clear. Again, if you look at the table, notice that there's many order pairs there, but notice there's that -1, 1, 0, 0, 1, 1. That's the 3 that we're identifying because they're the easiest. Now, if I go back to y equals and graph the second function, which is going to be the one with the transformations in it. So we have this x plus 5 squared minus 3. If we now graph that, it should move left and down. So notice how, here's my parent function, notice how it did go 1, 2, 3, 4, 5, and down 3 with respect to that vertex point. So if we look at our table, notice that instead of having -1, 1, let's see here, that don't look right. Huh. Okay, pause a second here. My fault. I forgot that if we want to compare our table, we have to now look and see if -6, -2 existed. So if I look at my table over here, got to go back to the X column for it to move up. Notice that -6, 2 does exist on this graph here. And does -5, notice that -5, -3 does exist. And notice that this -4, -2 exists. So those are the 3 critical points that we end up with, are those in the table. So I got to remember that we did change the x's and the y's this time. So if I want to graph this using the tools in the MyLab, we're going to be clicking on the parabola to start with. And then we should be able to click on this graph here. And then once I click on this graph here, I believe our goal is for this piece here to pop up. So we're looking for this piece here to kind of pop up for us. So notice that there's not any vertical stretches compression, so they'll stay as a coefficient of 1. But notice how there was a vertical shift. The vertical shift was down 3, so that's got changed to -3. And then there was a horizontal shift, and that was this +5 made it go left 5. So I have to put a -5 in there. And I don't need to check these boxes here because there aren't any reflections. It still did the same thing there. So that should all you have to change, and you should end up with the graph. If I clear off the parent function, this is the graph you should have on your graph here. It should look like the graph over here on our graphing calculator. So all you'll have to do is change the vertical shift and the horizontal shift, because the 5 here is going to be a horizontal shift, and again, it's backwards. And since this is on the outside, that's going to be the vertical shift of going down.